Hi, I'm David Ware. Let's look at how you build a truly fault-tolerant and scalable MQ messaging solution. It's quite simple, really. The principle is very simple. You want to move from the left to the right. The left-hand side, we have a single entity, something that we're highly dependent on. And if we look at its availability, it directly impacts what we can do. While that's not available, nothing is available. Whereas on the right, we don't have a single entity, we have multiple entities. Now with multiple entities, that means any particular problem with any one of those does not impact the entire system, greatly reducing the impact, greatly increasing the overall availability of your solution. And it's that fundamental principle that you then need to apply to your MQ solution. It's not just availability though, it also helps for scalability. From a scalable point of view, then if you have a system of a certain size, you can fill that to a certain level. And if I want to get more scale out of it, maybe I can grow that, maybe I can vertically increase the size of it, and I'll get to a certain level of that. But I'm ultimately going to have to hit a level where I can't go any further. Physical sizes are constrained. Whereas if I go the horizontal route and I scale horizontally, then I can move from having a single thing to multiple individual things which all process that same work, and therefore I can continue to scale past the limits of an individual system and increase the scalability further and further as I need it. And we don't have to stop there. We can continue going as far as realistically you need if those separate entities truly are independent. So that's the basic principles. Let's move back into IBM MQ. Let's look at what does that mean from an MQ queue manager deployment point of view. So here we have a single lonely queue manager. It's just sat there on its own. Now that's on a particular node, it's on a system, could be a machine, could be a virtual machine, could be a container, who really knows. But the point is, it's a single thing, it's running on its own. Now with that, I then have an application connected to it. And this is the first point where we start to look at what does it mean from an availability point of view. Before we even get into how do I make that queue manager, that MQ deployment, more highly available, let's first mention that from an application point of view, you really do need to take that into account first. You need to look at the application and think, okay then, how can I improve the availability of this application? Perhaps I could have multiple instances of the application. Maybe I could have them all running concurrently, and if I have any particular failure on any of those instances, I still have remaining instances to carry on that workload. So that's the first thing, look at your applications. Then we look at the infrastructure, and like I said, this is a very, very simple setup. I've got a single queue manager, no high availability, nothing set in place to recover that queue manager in the event of a problem. So if you then look at I've split it into system availability and message availability. So system availability means is the messaging system, is MQ available? Can applications connect to it and process work or submit new works, new messages? Message availability is looking at the individual messages. MQ provides queuing for messages, and with that means you need to be able to get back and access to those messages. And during a problem, when a queue manager isn't available, those messages will not be available. So if we look at the availability, you can see we could go easily from 100% available while the queue manager is running. Once the queue manager is unavailable, maybe you've brought it down for maintenance, maybe you've had a problem with the node or a problem with the queue manager. At that point, nothing is available. You're down to 0% availability. And because I've got no automated process in place here to bring that queue manager back online, I've got no backup node there ready to take over, it's going to take you a considerable period of time to get that system back online. Possibly indefinitely if you have a terminal failure of that node. And the same goes for the message availability. While that queue manager is not running, you cannot access any of the messages that were already queued in to that queue manager. So pretty much this is the system which gives you very, very low availability. So what do we do next? Well, the first thing to do is to bring in extra nodes to be backup systems, be systems where that queue manager could be running on. And those nodes are there as a way to be able to take over in the event of a problem with the node where the queue manager is active, or a problem with the queue manager itself. Now, there's multiple ways you can do this with MQ. I'm not going to go into details of them here. I'll put some links in the video. We've got multiple solutions. We've got replicated data queue managers, which gives you a very nice direct data replication between 3 nodes in an HA quorum. We've got MQ appliances that give you a way of replicating data between physical boxes. We've got other storage-based solutions like multi-instance queue managers, HA clusters. There are multiple ways that you can provide this sort of redundancy and resilience into an MQ system. So let's assume that is in place. Now at that point, we haven't fundamentally changed the fact that I've still got one queue manager. But what we have changed is the speed that you can get that queue manager back online. And if I can get it back online quickly, because I've got an HA system there monitoring, ready to take over, ready to detect a failure, and ready to bring that queue manager back up and running, then at that point, I can be up and running and processing my applications, processing my queued messages very, very quickly. And depending on which technology you want to use, then that could be anything from sort of sub-second to do a restart of a queue manager and force it over to another node, say for maintenance, to a few seconds, depending on what that queue manager is doing at the time. So it's a pretty fast and efficient way of bringing that queue manager back online, allowing the applications to connect back in again, and also them getting access to those messages. However, we have still got one queue manager in this picture. So that system availability and message availability goes from 100% right down to 0%, because while it's doing that quick failover, you still don't have any queue managers running that I can then process any messages off. So that takes us to a deployment like this. This deployment, if you look at the details, you can see I've now got 3 distinct queue managers. I've got queue manager 1, queue manager 2, and queue manager 3. Now the key thing here is they may be distinct, as in they are separate queue managers with their own high availability. You can see that they're available. They've got standby instances and replication happening across the other 2 nodes. But because they are effectively providing the same service, the same set of queues, the same ability for applications to connect into, I can distribute my application workload across those 3 different queue managers, and therefore I can distribute the risk as well. So if we look at the availability here, then you're going to see that actually any one failure does not take out the entire system. Now, specifically, if you look at the availability, it depends, because it depends on what those applications are doing and what their requirements are. And this is one of the subtleties in an approach like this active-active deployment style. So let's look at a situation where these applications have a certain level of affinity. Now, what does that mean? Well, each queue manager it may look the same as the other queue managers, but if I put a message onto a queue on that queue manager, say on queue manager 1, that message only exists on queue manager 1. It doesn't exist on queue manager 2 or 3. It may be replicating across nodes A, B, and C, but is it currently only available on queue manager 1? Which means maybe I've got strict ordering requirements. Maybe I've got a request reply flow and I need to get back to a particular place to get my reply message back. At that point, my applications might have some affinity burnt into them. So here what we've done is, okay, we've got an application which has maybe got 9 instances for availability, but we have tied 3 each of them to each of the 3 different queue managers. And that's quite simple. All you have to do is when I connect, I'm connecting to a specific queue manager still. So that's quite close to the sort of the single queue manager model. But if you then look at the availability, the difference here is if one of those queue managers becomes unavailable, you're not taking everything down to 0% availability. You're only taking it down to 2/3 availability, because the other 2 queue managers carry on running, which means 2/3 of those applications can carry on running unaffected completely. They don't see any problem. And it's only a subset of your application instances which are actually impacted by any outage. So that's pretty good. That gives you pretty good availability. And now I can start to think, well, maybe I don't have to worry so much about each individual queue manager. To take it the next step of availability, at that point, we need to look at situations where you've got no affinity. with no affinity, then it means these applications are able to connect into any one of those queue managers. They don't worry which one they're connected to. They might come into queue manager 1 second, but then they might come into queue manager 2 another second. So with that, that's more the sort of, I'm taking random messages off of queues, I'm processing them, I'm sending them on their way, and I don't really mind which instance of a queue I'm consuming from or producing to. Now that allows us to increase the availability even further. If we look here, the message availability stays the same because when one of those queue managers goes down, then a third of those messages are potentially locked away until that queue manager comes back up again a couple of seconds later. But the system availability has now been increased to 100%. It's always available because none of the application instances are tied exclusively to one of those queue managers, which means if they're connected, say, to queue manager 1 and queue manager 1 is shut down, those applications can instantly reconnect to any of the other queue managers and not worry about which one they're connected to. So from that point of view, my system availability stays at 100% at all times. And we've got a few nice tricks with MQ and capabilities to make it easy for you to write those applications and make those deployments. So is it a case of never go back? You just go for that last scenario, you just go with that? Well, it's not quite as simple as that. You know, hopefully you can see going to multiple queue manager approach is a lot nicer from an availability point of view. Single queue manager, I've still got to worry that actually at some point my system goes down to 0 availability. So it's not as good from an availability point of view. However, it is quite nice and simple. It's simple from an application point of view. The application doesn't have to think, oh, I've got multiple distinct partitions of that queue, and therefore I've got to worry which one I connect to. So if I've got any of those limitations I mentioned, like affinity, then I do have to consider that from an application point of view. But then there's all these downsides. The fact that if it goes offline, then what do my applications do? From a scaling point of view, I can only take it so far. Whereas if you look on the right, multiple queue managers all working together, then that does give you the greatest level of availability and the greatest level of scalability as well. But you do have to think about your applications slightly differently. You have to build in that model into the applications right from the start. So ideally, you can stop thinking about an individual queue manager. Rather than thinking of an individual queue manager each time you're looking at a highly available system, really do consider how I can build that into multiple queue managers. Now, I'm not saying you can do that for every single pattern, as we've just discussed, but at least consider that as a starting point, because the best way to think about it is as a single thing, which is a group of queue managers. And with a group of queue managers, if I can apply that from an application point of view, then I am going to get the highest availability and scalability out of your MQ system. Now, I'll also point you to a new capability which we've had in MQ for a few months now, called a uniform cluster. Now, a uniform cluster is a new way of building these multi-queue manager deployments to ensure that your applications are evenly distributed across all of those queue managers, automatically balanced, and see how that goes into the future. At that point, I'll stop and I'll put some links below so that you can go find more information. Thank you.